Hello students, in this lecture we will take next topic of the first chapter, mechatronics design process. So in the previous lecture we have taken examples of the mechatronics system, that is a CD player and also camcorder. So what is mechatronic design process? So in the mechatronic design process, uh, generally there is a flow as shown in this block diagram. So to design any mechatronic system, first we have to identify the needs. That is this is the first step. We have to identify needs and wants of the market. What are the needs and wants of the market? And according to that, we have to design the process. So first is a identifying need. Second, analyzing the problem. So analysis of problem is a important step. Second step. Then preparing specification. After analyzing the problem, we have to prepare the specifications for that. Then after preparing specification, next step is a generate possible solution for that. Okay, then select suitable solution, generate possible solution, n number of solution, brainstorm, you can brainstorm the for the solution, and select suitable solution for that. Then detailed design, and last is implement that design. So these are the mechatronic design process. So keep in mind this block diagram. So one by one we will explain some points. So first, as previously mentioned in block diagram, identifying need. By adequate market research and knowledge, the potential needs of customer can be clearly identified. In some cases, company may create a market need, but failures are more in this area. So market survey or research survey, can say it as a literature survey. So according to that, what are the needs and wants of the market? According to that, we have to identify the needs. Then analyze the problem, analyzing the problem. After knowing the customer need, analysis should be done to know the true nature of the problem. To define the problem accurately, analysis should be done carefully. Then third is preparing specifications. The specifications must be given to understand the requirements and the functions to meet. Then next, four, that is a generate possible solution. As this is a fourth step, it is generated by verifying the old problems or some newly developed techniques may be used. Then fifth is select best solution. So n number of solutions available, we have to select best solution. It is also called as a optimization technique. Then sixth is a detailed design. After providing best solution, we have to provide mechanical layout, or we have to make a prototype of that, and according to that we have to follow the procedure. Then seventh last step is after detailed design, we have to implement that design. Okay, so these are the mechatronics design process. Then next, so this is a more detailed figure about the mechatronics design process. So first, there are three stages in mechatronics design, that is a modeling or simulation, then prototyping, and deployment life cycle. So first is a recognition of need, as previously mentioned, then conceptual design and functional specification, as previously mentioned, then first principle modular mathematical modeling, then sensors and actuator selection, then detail model mathematical modeling, control system design, designs uh, optimization, then prototyping, as previously mentioned. We have to provide the mechanical model or prototype of that, that is a hardware in the loop simulation, and design optimization. So in the simulation, whether we are getting the result, we have to check, and it is also called as prototyping. Then after design optimization, deployment life cycle is there. In that deployment of embedded software, then life cycle optimization. So this is a detailed block diagram, or you can draw a previous diagram. So in more detail, this diagram is here provided to you. So the mechatronic design process consists of, as previously mentioned, three phases. That is modeling, simulation, prototyping, and deployment. All modeling, whether based on first principles or the more detailed physics, should be modular in structure. A first principle model is a simple model that captures some of the fundamental behavior of the system. A detailed model is an extension of the first principle model, providing more function and accuracy than the first level model. Complex models may be created by connecting the models or blocks together. Then, as previously mentioned, there is a next is a modeling. Modeling, as previously mentioned, block diagram or visual interface is called as a modeling. Then that is a identifying need. We have to prepare a block diagram to understand the concept of that. We have to prepare a block diagram. Then simulation, numerical methods for solving the models containing differential, discrete, hybrid, partial, and implicit nonlinear, uh, as well as linear equations are used for the simulation, or some software simulation softwares we can use for the simulation. Then next is a project management database for maintaining the project information and submodels for the eventual reuse. Then design, for designing numerical methods for constraint optimization of performance function based on model parameters and signals. So this is a design process. Then next is the analysis. For that, numerical methods are used to analyze the problem. Then real-time interface. A plug-in card is used to replace a part of the model with actual hardware by interfacing to it with actuators and sensors. This is called hardware in the loop simulation or rapid prototyping, and must be executed in a real time. The next is a code generator to produce efficient high-level source code from the block diagram or visual modeling interface. The control code will be compiled and used on the embedded processor. The language is usually C. So usually C language is preferred, or you can add that in that C++ language. Then embedded processor interface. The embedded processor resides in the final product, and this feature provides communication between it and the computer-aided prototyping environment. This is called a full system prototype. The mechatronic design approach also uses a model-based approach, relying heavily on modeling and simulation. However, unmodeled errors are accounted for the prototyping step. Their effects are absorbed into the design, which significantly raises the probability of successful product deployment. So this is a design approach. And next is in the prototyping step, many of the nano computer subsystems of the model are replaced with actual hardware. So this is an important step. In the prototyping step, many of the nano computer subsystem of the model are replaced with actual hardware. So sensors and actuators, as previously mentioned, these sensors and actuators are the key elements of the mechatronics. So sensors and actuators provide interface signals necessary to connect the hardware subsystem back to the model. The resulting model is part mathematical and partial. This process of fusing and synchronizing model, sensors and actuators information is called a real-time interfacing or hardware in the loop simulation, and is an essential ingredient in the modeling and simulating environment. So this is a process of fusing and synchronizing model. So as previously mentioned, as this word fusing, that is a mechatronics is a provides the multidisciplinary approach. So this fusing word is important, which you can say it as a fusing, integrating or multidisciplinary approach. Okay? And synchronizing the model. Synchronizing is a very important step also. In order to produce high quality products at low life cycle cost, many manufacturing plants have been reducing their workforce. So this is an important step towards in the industries. Now there is a reduction in their workforce. As a result, the reduced workforce has to cope with additional tasks and responsibilities. So reduced workforce are reduced employees in from the industries. In number of industries, there is a reduction in employees are there, and as a result the reduced workforce has to cope with additional tasks and responsibilities. Model-based monitoring using intelligent sensors is an important technology holding much promise for improving manufacturing productivity and quality. So this intelligent sensors plays also very important role. That is it provides the correct information. Either we can use manual, but intelligent sensors provide the correct information. Therefore, it is an important technology holding much promise for improving manufacturing productivity and quality. So productivity increases, then time decreases. So this is and also quality is also increased. Quality of that product is also increased due to the intelligent sensors. N number of sensors are used. Then integrated design approach. So this is a subtopic of this chapter, integrated design approach. That is the integration of as in the W. Bolton books definition of mechatronics, there is an integration of mechanical, computer, electrical, then IT or IoT. So integrated design approach is a very important. So in the integrated design approach, there is a combination of hardware, software, information processing. Then also there is a computers are used, then actuators, then sensors are used, and that process the knowledge is again given to the hardware and software, and also sensors feedback is again given to the computers to provide the correct action. Okay, so this is a integrated design approach. So in the integrated design approach, mechatronics makes the combination of actuators, sensors, control system and computers in the design process possible. Starting with the basic design and progressing through the manufacturing phase, mechatronic design optimizes the parameter at each phase to produce quality product in a short cycle time. As we have previously mentioned, we get the quality product, also time is reduced, and also production speed also increases. So these parameters, that is a basic design and progressing through the manufacturing phase, mechatronic design optimizes the parameters and each phase to produce a good quality products. Mechatronics uses the control system to provide coherent framework of component interactions for the system analysis. So this feedback is also important, coherent framework, and uses the control system to provide a coherent framework of a component interaction for system analysis. Okay, so this plays very important role, that is a control system. The integration with the mechatronic system is performed through the combination of hardware and software, that is the hardware components and software information processing. So in the software languages you can use for the software as previously mentioned C, C++. In hardware you can use n number of hardware components. Then next is hardware integration results from designing the mechatronic system as an overall system and bridging together the sensors, actuators and microcomputers into mechanical system. So as this is an integration, so integration of or hardware integration results from designing the mechatronic system as an overall system and bringing together the sensors, actuators and microcomputers into mechanical system. Software integration is primarily based on the advanced control functions. So this integration word is very important. So you can add in this integration of, that is different branches or combination of different branches, different softwares, hardwares, and also sensors, actuators. So combination of all these provide the integration, and to provide this that integration, proper synchronization between the different components is required. So mechatronic system provide a best solution to that problem. So this is a mechatronics design process as we have mentioned in this lecture. So keep in mind, so for designing any project, for either for your electronics project, you can apply this concept process, design process, that is for designing any project we have to first identify the needs and wants of the market. Then we have to analyze that problem by brainstorming. Then after analyzing that problem we have to provide the best solution, n number of solutions, or we have to provide best solution, and also we have to provide the optimization technique. Also we have to use of after optimization, we have to provide software integration, that is in software and hardware integration is must be there. And in software you can use different languages and provide. Then next is we have to provide the prototype model as previously mentioned. Prototype model or simulation is performed first, then actual design, you can design the mechatronic system after getting good simulation result. So providing the prototype model के बाद you can lastly actual work or process to provide the solution by using all these. Okay, so this is a mechatronics design process. So write short note on mechatronic design process or explain mechatronics design process. Such a type of questions are asked in exam, so you have to prepare. And this is a theoretical concept, so mainly first block diagram is very important. You have to draw the diagrams. So in exam time is very less, so you have to make a practice for recalling such a type of questions, or for theory type topics we have to make diagrams or draw the diagrams properly, so you can uh, write more in detail in exam. Okay, so we'll stop here. In the next lecture we'll take next topics, that is mechanical components we have to study. Mechanical components, in that we have to study spring. Then we have to study mass, inertia, this type of a concept. That is the mechanical components we have to study that are used in mechatronics. And these components plays also important role in the mechatronics. So we will take in the next lecture. Also we have to take the servo mechanism. So servo mechanism In that we have to take in details more about the what is servo mechanism. So we'll stop here, and in the you have to revise this subject, and also you can use book of W Bolton for this subject, and you can prepare self notes also for this subject. Make a separate notebook for this subject, and try to draw the more diagrams. So if you practice more diagrams, then you can draw these diagrams properly in the exam, so your presentation becomes good and you can score this subject. Okay, so we'll stop here. Thank you.